Jiangsu Zhongding Environmental Engineering Company, Limited. The Hazardous Waste Disposal Center is mainly used for incinerating medical waste, hazardous waste, and general industrial solid waste. It can handle various forms of hazardous waste such as liquid, solid, and semi-solid, and ensure the emission of flue gas meets the standards after incineration. The waste goes through a pre-treatment system first. Wastes with a particle size less than 150 mm are directly sent to the garbage storage pit. Large materials or barrel waste flow into the storage pit after being crushed by the crusher. Different calorific values, compositions, and forms of garbage are matched with parameters such as composition and calorific value. Thoroughly mix in the mixing area using a grab bucket. Then the waste enters the feeding system. After mixing, the bulk waste is sent into the upper receiving hopper of the plate feeder by the grab bucket, and is continuously and uniformly fed into the head hopper of the plate feeder through the uniform material distribution device of the plate feeder. Bulky trash, certain hazardous materials that can only go directly into the furnace, are sent into the top hopper by a vertical lifting machine. In case of a malfunction in the feeding system, the lifting machine can serve as an alternative feed channel. When the waste reaches a certain amount, the first level seal door in the chute opens automatically, controlled by the program, allowing the waste to fall between the first and second tier doors. The first level seal door closes automatically, while the second level seal door opens automatically. The waste slides into the rotary kiln for incineration, relying on gravity through the water-cooled feeding chute. After the second level seal door closes automatically, one feeding process is completed. A hydraulic push rod device is used to assist the feeding chute into the furnace, periodically clearing any blockages in the chute. After pre-treatment, the waste liquid is pressurized by a waste liquid pump and atomized by compressed air, then sent to the rotary kiln or secondary combustion for incineration. The waste goes into the rotary kiln for 30 to 120 minutes, passing through the drying, volatile release, and incineration stages, resulting in significant volume reduction. The incineration residues are continuously discharged from the bottom water-cooled slag discharge system. The smoke, at approximately 850 degrees, from incineration in the rotary kiln enters the secondary combustion chamber. It undergoes complete combustion under the effect of secondary air and, aided by the combination burner, is kept above 1150 degrees Celsius for over 2 seconds in the chamber. This process thoroughly oxidizes and decomposes various organic compounds and dioxins. High-temperature flue gas generated by gas enters the heat recovery boiler to recycle energy. Meanwhile, urea solution is set in the temperature range of 900 to 1000 degrees Celsius in the heat recovery boiler. The urea solution is sprayed into the boiler through a gun to reduce NOx by non-catalytic reduction. The heat recovered by the heat recovery boiler produces steam. Part of the steam is used for heating the flue gas after wet desulfurization, providing heat for related equipment and other process gases. Excess steam can be used according to the owner's requirements. In the absence of external steam usage, a steam condensing system is set up. Steam can be reused by recovering condensate through condensation. Finally, the flue gas enters the flue gas purification system. After the residual heat of the heat recovery boiler is utilized, the temperature reaches 550 degrees. Then it enters the energy-saving tower, where it rapidly cools from 550 degrees to below 200 degrees in 1 second to prevent dioxins from resynthesizing between 200 and 500 degrees. After the flue gas is discharged from the energy-saving tower, it enters the dry desulfurization tower, where lime powder and activated carbon powder are sprayed into the tower. In the flue, lime undergoes acid-base neutralization reactions. Activated carbon adsorbs heavy metals and dioxins. Subsequently, the bag filter removes suspended particles from the flue gas. At the same time, the lime powder and activated carbon, which are slightly surface adsorbed, further undergo acid-base neutralization reactions and adsorb heavy metals and dioxins. The fly ash is discharged through a screw conveyor and ash discharge valve and sent to the solidification workshop for solidification treatment. At the outlet pipe of the bag filter, ozone is injected through an aeration device to oxidize nitrogen oxides into higher valence nitrogen oxides using the strong oxidizing properties of ozone. The flue gas is sent into the primary and secondary desulfurization scrubbers by the induced draft fan. In the scrubber, nitrogen oxides and sulfur dioxide are simultaneously absorbed and converted into water-soluble substances. Efficient removal of nitrogen oxides is achieved by combining the tail valve scrubber. At the same time, the circulating solution neutralizes acidic gases to denitrify the flue gas. 2 stages of demisters are installed at the top of the secondary desulfurization tower, removing water mist from the flue gas to reduce its impact on the subsequent wet electrostatic precipitator. The demister removed flue gas at around 70 degrees enters the high-efficiency wet electrostatic precipitator, where dust and water mist are removed under a strong electric field. The flue gas is heated by a reheater to a temperature of 130 to 140 degrees Celsius before being discharged through the chimney.